Okay, so we're going to look at taking the radical of a variable with exponents. So for example, the square root of x squared, well, this really works the same way. The index of 2 cancels the exponent of 2, so I am left with x. However, we learned that when it is an even exponent, an even index, my answer must always be positive. X may not be positive right now because x is standing for some value. To assure that x is positive, I'm going to put absolute value bars around it. Square root of x to the 6th. Okay. Now, my advice here, I could write it as x squared, x squared, x squared, and that would give me x, or x cubed. But a shortcut would be to take my exponent for the variable and divide it by my index. So there's my exponent, here's my index. And when I do that, I get x cubed. Now again, I'm talking about an even index. I am talking about a value that must be positive. So either way that I do the problem, I've got to put absolute value bars around my answer to assure that it is positive. The square root of x to the 8th, I'm going to use my little shortcut there. 8 divided by 2 is 4. So that's x to the 4th. Even index, oh wait a minute, x raised to an even power is going to be positive no matter what. So in this case, I do not need the absolute value bars because raising something to a 4th power is going to result in a positive value whether x is positive or negative. When my index is even, if my resulting exponent is also even, I do not need the absolute value bars. So what happens if I have the square root of a number with a variable with an exponent? So in this case, it's the square root of 4 times the square root of x to the 6th, which is 2x cubed. Even index, better make that x cubed positive. How about if I have a cube root? No problem, works the same way. 12 divided by 3 is 4, x to the 4th. Now something for us to know regarding cube roots is that my answer is what it is. My answer is allowed to be negative. So I don't ever have to worry when I have an odd index about the sign of my answer. This could be positive or negative. It's no problem either way. Now if I have the square root of something that does not divide evenly by my index, so 7 divided by 2 is 3 with 1 left over. So that means I'm going to have x cubed outside and then x to the 1st on the inside. And that x cubed on the outside needs to be put in absolute value bars. If I have the cube root of x to the 8th, 8 divided by 3 is 2 with a remainder of 2. So that's x squared. And then the cube root of x squared, I don't have to worry about making this positive or negative. One more example. The cube root of x to the 9th, y to the 14th, z squared. 9 divided by 3 is 3. 14 divided by 3 is 4, remainder 2. And 2 does not divide by 3. So, I have x cubed outside, odd index, so I don't have to worry about any signs. I have y to the 4th outside. I have no z's outside. My cube root of, I have no x's inside. I have y squared inside, and I have z squared inside.